In lesson 311, we are going to learn to break apart and add fractions. Tomorrow we'll be playing a game called Fraction Capture. But today you'll need your whiteboard and your math journal. So let's go ahead and on our whiteboards, I want you to write at least 2 fraction addition problems that have a sum of 7/6. So remember, the denominator must be 6 and the numerators must add up to 7. Go ahead and pause your video and write down at least 2 different ways that you can add some fractions with a denominator 6 that the numerator would equal 7. I could do 4/6 plus 3/6, that would equal 7/6. I could do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. Break it down into what we call unit fractions. I could do 5/6 plus 1/6 plus 1/6 would equal 7/6. Is 7/6 greater than or less than 1 whole? Remember, when the numerator is larger than the denominator, it equals more than 1. So let's break apart this fraction. On your whiteboard, go ahead and erase. Come up with another way to write 9/5. Remember, fifths will not change. All of the fractions that we add together will have fifths. Go ahead and pause your video. All right, I could do 5/5 plus 4/5 equals 9/5. I could do 3/5 plus 3/5 plus 3/5. So there are many different ways to represent 9/5 as a sum of smaller fractions. Now let's take 5/8. This time I want you to do 2 different ways. And I want one of those ways to be a fraction that does not have eighths as the denominator. So think of other ways that you could say eighths. Here's a little clue. Make sure you pause your video while you're working on your whiteboard. Well, one way using eighths, so I could say 2/8 plus 2/8 plus 1/8, that equals 5/8. Now, I'm going to think of another way to say eighths. Let's say 4/8. What's another way I could say 4/8? Well, I know that they have a common factor of 2. I could divide a 2 out of both. 4 divided by 2 is 2, and 8 divided by 2 is 4. So 2/4 would be the same as 4/8. So keeping that in mind, then I would add 1/8 to it, because 2/4 is the same as 4/8, and this would equal 5/8. Another way that I could do that is for example, take 6/8 plus 1/8. But now let's change 6/8. What's another equivalent fraction? If I divide each one by 2, 6 divided by 2 is 3, and 8 divided by 2 is 4. So 3/4 is the same as 6/8. So I could say 3/4 plus 1/8 would be the same as 5/8. Let's try another one. Actually, let's go right into our math journal. We're going to go ahead and move to page 99. It says renaming fractions and mixed numbers. Fractions greater than 1 can be expressed as mixed numbers, such as 2 1/3 and 1 4/3. And as fractions with a numerator larger than the denominator, such as 7/3. You know several ways to rename fractions as mixed numbers and mixed numbers as fractions. So you can use your fraction circle pieces from the back of your math journal, or you can use the e-tools on ConnectEd McGraw-Hill. So it says, show the original number, make fair trades between wholes and same pieces. So in this example here, They are taking 2 1/3, and they replaced 1 whole with 3/3. They also replaced 1 whole with another 3/3. So it's the same amount, but you can see 7/3 is the same as 1 4/3, which is the same as 2 1/3. You can also use number lines. Use fraction names for whole numbers and count up. The number line on the left shows that 2 1/3 is 4/3 past 1. So 2 1/3 is the same as 1 4/3. The number line on the right shows that 2 is the same as 6/3. And that 2 1/3 and 7/3 are both 1/3 past 2. So 2 1/3 is the same as 7/3. For problems 1 through 3, rename each fraction as a mixed number. Make as many wholes as you can. So what I'm going to do is I'm going to take 4/4, which is equal to 1, and another 4/4, which is equal to 1 whole. 8/4 is the same as 2 1 whole and 2. So this would be 2 wholes. And then if I subtract 8/4 from it, I have 1 left. So 2 1/4. 12/5. 12/5, I could make 5/5. That's equal to 1 whole. And another 5/5 is equal to another whole. So that's 2 whole, and 5 plus 5 is 10/5. And then I have 2 left. Oops, fifths, sorry about that. 2 2/5. For number 3, 15/8, I can take 8/8 away from it. That equals 1 whole. I can't do another one because that would be 16/8. So I end up with 1. If I subtract 8 from this, I end up with 7/8. Remember, the denominator never changes. For problems 4 through 6, write at least 2 other names with the same denominator for each mixed number. Well, I'm going to borrow one from here and just make it equal to 4/5. So this would be 5/5. And then 5/5 would be the same as the one that I borrowed. So add that to what's already there to get 2 9/5. Another way to say that is I can multiply the denominator times the whole number and add the numerator. So 5 times 3 is 15. 15 plus 4 is 19/5. Number 5, 2 1/6. I'm going to take 1 from here and make that fraction equal to 1 whole. Add the 6/6 to the 1/6 that's already there to get 1 7/6. I can borrow 2 from there. Remember, 6 is not going to change. So if I borrow 1 from there, that would equal 6/6. And I'm going to borrow 1 more and make that equal to 6/6. 6 plus 6 plus 1 is 13, and the denominator does not change, 13/6. For problems 7 through 9, fill in the missing whole number or the missing numerator. So here's what you do. You take the denominator times the whole number and add in the numerator, the top number. Okay, so remember that. So 5 times 4 is 20 plus 2 is 22. Another way to think of that is to change 4 into fifths. So that would equal 1 whole, 2 wholes, 3 wholes, 4. Then add those all up. 5, 10, 15, 20, 22. Now for number 8, if I take 8/8 plus 8/8 equals 16/8, I subtract 16 from that, I end up with the 2. So it equals 2 2/8. Here they added 1 whole to it, so 1 whole would be the same as 3/3. So go ahead and subtract 3/3 from that. You would end up with 3 2/3. That is it for today's lesson. Tomorrow you'll learn to play fraction capture.